In a rat, when a side is unknown, we usually rely on Pythagoras. But what if an angle is unknown or two angles are unknown? I say that because we know that in a rat, one of the angles will always be 90. Okay, but what if two angles are missing? That will eliminate the option of using interior angles of a triangle. So we have our triangle, we have our 90, and we have theta. So Pythagoras is limited to sides or lengths, and the interior angles of a triangle require two angles given. We can't use int angles triangle unless we have two given angles and one missing angle. But when we look at sine theta, who we know is equal to opposite over hypotenuse, we can see that we have one angle, our theta, and we have two sides, the opposite side and the hypotenuse. And so our trig ratios really opens up the possibility of us finding angles and sides should we be required to find them. Example 9. Before we can even look at this example, we must remember our BODMAS for trigonometry. So Katoa, this is integral to being able to answer any question where we apply the trig ratios to find sides and angles. So in triangle fun, Fn is 10, angle U is 90, angle in is 28. Calculate the length of Fu rounded to a single decimal place. Right, we see the 90, which means that this is a rat and all our trig ratios are applicable. So we're going to do this in 3 steps. Step 1, what do you have? You have that angle 28 degrees. You also have the hypotenuse, which is 10 units. The second question is, what do you want? And we get that from the information. What we want is Fu. The third question is, what can we use to find Fu? We can use sine. Why? Because I have the hypotenuse and I want the opposite. And the only ratio that goes with the opposite and the hypotenuse is sine or sin, right? And so we set up our equation by saying that sine of 28 is opposite over hypotenuse. Sine of 28 is Fu over 10. So there we have a nice equation where Fu is the unknown and we just have to manipulate that to find our answer. Now I want you guys to be able to do this in the simplest possible way, and we're going to do that by using another triangle. So sine 28, bottom left, Fu on top, oops, and 10 in bottom right. So we can see that Fu is sine 28 times 10, or rather 10 sine 28, always with the coefficient in the front, and so Fu is 10 times sine 28, which gives us 47 units. I just want to go back to the triangle. How did I form this triangle? When you have a 3-variable equation like this, similar to the speed, distance, time one from grade 9, this one, your answer is always, well, your left hand side will be your bottom left, this will be on top, this will be at the bottom. So should you want to find this one in the bottom right, you would say Fu over sine 28. Should you want this one, you would say Fu over 10. So just keep that in mind. Example 10 reads, consider the triangle sketched alongside. Calculate the length of ON correct to 1 decimal place. 3 steps. What do you have? You have the opposite side to our 57 degree. We have the 57 degree angle. The next question is, what do you want? We want ON, this one. And we notice that ON is the adjacent side to the 57. What do you have is our last question. or sorry, what can you use? We have the opposite, we want the adjacent, and the only ratio that has opposite and adjacent is tan, and subtangent is the ratio that we want. So we write our equation. Tan 57 is opposite over adjacent, which substituted is 12.1 over 0n, sorry. We use our little triangle, tan 57 bottom left, 12.1 in the top, and ON in the bottom. So for us to get ON, we say 12.1 divided by tan 57, which gives us 7,9. This is a mistake on my part over here. That should be ON.